Alright, recording has started, and I'll take you to the practice quiz, and there's a note in the schedule. It says today in our official schedule that we're doing a circles worksheet today. We are skipping the circles worksheet. I've taken it out of the modules for the homework list. There's no circle worksheets for homework either, although it says that in the schedule. I've revised the schedule slightly because it was just a little too aggressive on what we were trying to accomplish. Okay, problem number 1. Consider the line segment from the point 25 to the point 6, -3. Write the midpoint and distance formulas from memory. And then I'm going to have you compute the distance and midpoint of this. But first, you write the formulas from memory. And then we'll check to make sure you have the formulas down correct. And then we'll actually use them. "30 seconds more for just writing the formulas down from memory. Now, what's most interesting in these when you write them down from memory is not what you remember, but what parts you remember and what parts you can't remember. And then it really focuses your attention when you figure that out. And then the part that you couldn't remember, often that becomes the part you remember the best. Alright, so the midpoint formula. If we think of the points as x1, y1, second point x2, y2, the midpoint formula is the average x-coordinate and the average y-coordinate. Averages. The distance formula equals square root of x2 minus x1 squared plus y2 minus y1 squared. And if you squared both sides, it would be d squared equals this squared plus this squared. This comes from the Pythagorean theorem. From a right triangle. Alright, so those are the two formulas. Now that you know that you have them right, find the midpoint of the line segment and the length of the line segment. A minute for that. Okay, 30 seconds more. Okay, the midpoint, the two x coordinates are 2 and 6. Two y coordinates are 5 and -3. So the midpoint is the point 4,1. And then the distance formula so we're going to take the difference in the x coordinates, difference in the y coordinates, we square each of those and add them together, and 4 squared plus -8 squared, 16 plus 64, which is square root of 80, and that would be, we had radicals, oh, have we done this part yet? Where you break that up into 2 square roots? Where one's a perfect square. Does this look familiar? I don't remember because I'm teaching 4 different classes. Have we done this in this class? 4 and 20. Does this look familiar to anybody, or is this, we haven't done this?
Yeah, I think we've done it before.
We've done this? Okay. And then we could do it again. 20 is 4 times 5. So then this becomes a 2. And then we get this. Okay, so the distance is 4 squared of 5. And if you punch this out on a calculator, let me punch it real quick. I get 8.9. Alright, so the last thing I want you to do with this is, let me insert some space. First of all, alright, draw these 2 points on an XY grid and show the legs of the triangle and show the midpoint and show that all this stuff makes sense in terms of the diagram. So let me give you a minute for making your diagram. Give you 30 more seconds. Okay, 2, 5, and 6, -3. Two over. Three, 4, 5, 6. -3. We connect these two together. Now, we found that the midpoint was 4, 1. And does that look reasonable? If I go 1, 2, 3, 4 over 1 up, it's right about, my 4, 1 is right here. But if my graph was, more to scale, I think it's pretty close. Okay? And then the triangle from here to here, this looks like it's 8 high because you go 3 to get to the x-axis and then 5 more, so that's 8. And then you go over here from 2 to 6, that's 4. And that's exactly what we were doing, 4 squared and 8 squared. And it says that this distance is about 9. Well, it's going to be a little bit longer than 8, because that's the distance straight down, put it at a little bit of a tilt. That all seems reasonable. Okay, give me a little feedback on this. Was this review significant? Didn't need it? Helpful or not? You can use the protocol 1, 2, 3 and go ahead and hit enter. And all right, the next two problems. Find 8 to the negative 2/3 power and then solve that equation. Okay, so 30 seconds more. All right, so we'll take care of the negative exponent first. Anything is itself over 1. Because it's a negative exponent, you bring it down to the bottom and you make the exponent positive. Negative exponents don't give negative results, it gives fractional results, really small positive results. And then these two exponents are at war. If they were the same size, they would dual each other off and the 8 would stay the same. The bottom number is trying to make it smaller, cube rooting. The top number is trying to make it larger. And we can do it in either order. We can make it smaller first or larger. If I make it larger first, I'm going to have to do the cube root of 64. So I'm going to make it smaller first and then larger. Cube root of 8 is 2. 2 squared and I totally get 1/4 at the end of that. Okay, and then on number 3, the steps are to solve an equation containing square roots, isolate the square root. Once you isolate the square root, we then square both sides. But it's at this point right here that I can stop and say, no solution. How do I know that there's no solution? Because when you take the square root of anything, because this is, you take 2x plus 3 first, and then you take the square root, you always get a positive result, or 0. So you can never get it. The square root sign means the principal square root, the positive square root. Now, if you followed the procedure and squared both sides, you would get, this is not what we're supposed to do. I'm supposed to just stop right there, but if you did that, we'd be okay. Because we'd get 2x equals 6, divide by 2. And we'd get x equals 3. What would save us would be that we would check our work. Remember, checking is mandatory with these when they have square roots. 11 plus the square root, now it's going to be 6 plus 3, and that's 9. And 11 plus the square root of 9 is 3, is 14, and 14 does not equal 8. So then we would say, you have to throw out the solution. So it doesn't check. Alright, so give me feedback on either or both of these, 2 or 3. Type that up, don't hit enter quite yet. Go ahead and hit enter. And number 4. Alright, now this was a problem that we were going to get to the last class, but we didn't quite get enough time to do it. So I'm putting it in the practice quiz here. So you've done some solving of square root equations. Go ahead and take the first step, the first couple steps of this. I'm just going to give you a minute to get started. Okay, just a little bit more time. All right, so what not to do. I'll start out because this would be my first instinct. Would be to do this. And my next instinct would say, distribute the squared to both. Distribute the squared to this. Equals 1 squared. And the problem with this is that you can't distribute this exponent to both of these things. If you're going to square the difference of two things, you have to FOIL it out. And so this would not be the right answer, even if we put this in parentheses. You can't, let me, x minus 3 squared is not x squared minus 9. What it is x minus 3 squared is x minus 3 times x minus 3, and you have to FOIL it out. X squared minus 3x minus another 3x plus 9. That's the way you have to do this. All right, but we wouldn't want to even do this right at the beginning, because we have two expressions that both contain square roots, and we have them both on the left side. And if we had to FOIL this out on the left, that middle term is going to be a really nasty middle term. It'll have these two things multiplied together, and you'll get it twice. And so what we do is, correctly now, you start by adding square root of x plus 1 to both sides. So you move one of the square roots to the other side. So you have one square root on each side. Once you have that, then we're going to square both sides. When you square both sides, you have to square the entire side. You can't put separate squares around the individual terms. Alright, so now this is going to give us an easier, the middle term is still going to be there. It's going to be a bit of a mess, but it won't be as bad as when we had both square roots on the same side. Square root and the square cancel each other out. Over here we get, now that's a lazy square root sign. It's not clear whether that 1 is underneath the square root or not. You have to be really clear with that. Make sure you go way over. Okay, and then we got to FOIL out the right hand side. 1 times the 1 is the 1, and 1 times the square root of x plus 1, and then you can move to the square root of x plus 1, multiply that over, and when you do the square root of x plus 1 times square root of x plus 1, the square roots go away. I'll put pretend parentheses around this to kind of show that it all came in at one time. Alright, now, what we notice is that we squared both sides, and we didn't get rid of all the square roots. Our objective was, why did we square both sides? To get rid of the square root signs. But we're going to have a simpler square root. These two are like terms. We can put them together. And so, although we still have square roots, we don't have two separate terms that have square roots. It will be just one term when we put them together. So I'm going to get 2x plus 3 equals, the 1 and the 1 make 2. And then this x I'm going to put next. And then these two together are like terms. One of these plus one of these makes 2 of those. And now we can do what we learned to do, which is isolate the square root. So I'm going to move all the other terms to the other side. And I'm going to subtract 2 from both sides. I'm going to get x plus 1 plus, and then I'm going to furthermore isolate the square root. So I'm going to divide both sides by 2. Okay, so I got the square root all by itself. Once you get the square root all by itself, square both sides. This can be a long problem. The right side is going to be simple. The square root and the square kill each other off. The left side becomes x plus 1 times x plus 1, because that's what you get when you square it, times itself, over 4. 2 times itself is 4. Here the square root and the square cancel each other off. Okay. Next, I'm going to multiply both sides by 4. Now, the 4 is really 4 over 1. That gets rid of the fraction over here. And what I'm left with is x plus 1 times x plus 1 is equal to 4x plus 4. Still, I have to FOIL out this left-hand side. X squared plus x plus another x plus 1. Okay, so this becomes x squared plus 2x plus 1 is equal to 4x plus 4. And then, what type of equation is this? It's called a quadratic equation. We get those solved by setting them equal to 0. And then once we have it equal to 0, we factor it, and if it doesn't factor, we use a quadratic formula. And it's minus 3, minus and plus to get a negative, and then 3 and 1, and make the larger one negative so the middle term is negative. And then we get two answers, x equals 3 and x equals -1. I'd love to stop here, but I can't. I have to check. Remember, because square equations have square roots and we square both sides, we might get an extraneous solution. So this, copy it. No, that's not the one. This one. Here, that's the equation. I'm going to copy it down over here. And I'm going to plug in x equals 3. I would get square root of 6 plus 9 plus, no, minus square root 3 plus 1 is 4. Now this becomes, oh, it's not 6 plus 9, it's 6 plus 3. I was jumping right to the answer. So this is square root of 9 minus square root of 4, which is 3 minus 2, which is 1. And that's what it's supposed to be. So 3 works. We're going to check. X equals -1, the other proposed solution here. And if I do that, I'm going to get, plug it in here, I'm going to get -2 plus 3, square root -2 plus 3, minus square root of -1 plus 1. Now this is square root of 1 minus square root of 0. This is 1 minus 0, which is 1, which is what it's supposed to be. This is kind of an unusual one. Both answers. Check. Very often you get one of them works and the other one doesn't. So here's my solution. They both checked. That was a long one. It was the most complicated type of the square root types. Just give me a little feedback. Did that make sense? Had you already figured it out? Was it confusing to you? Did I go too fast? Go ahead and type up some feedback and hit enter. And that's it for practice quiz. Questions on homework or anything else? You'll notice your midterm grades have been entered. You can always keep track of your grade. Canvas is great on that because it gives you your total average. And if you're somewhere in the 90s, you have some form of an A. Somewhere in the 80s, you have some form of a B, etc. But also, your midterm grades have been submitted as well.
Hi, Mr. Shankin.
Hi.
I had a question on 2.6, numbers 24 and 26.
All right, let's start with 24. 2.6, number 24. And 59. Okay, 24. Well, you had 24 and 26, so I'll put them both.
Mr. Shankin,
Yeah.
I had the numbers that I had trouble with written down, but I realized that you just did 26, so you don't have to do that one.
All right, so it's just 24. Okay. So all right, these are the ones that are going to get us, hopefully, into a new mode of looking at math, where instead of just following the procedures, we stop very often and we say, does this make sense? When you take the square root of any number, remember the practice quiz from, I think it was the last time we had class, we don't get plus or minus 3, we just get 3. The square root symbol was made to be a function, and so it means the principal square root. You only get the positive one. So if t was, let's say, 8, 8 plus 1 would be 9. The square root of 9 would be positive 3. You can only get positive numbers. This, we can immediately say, is no solution. As soon as you isolate the square root and it's equal to a negative value, you can stop right there and be done. No solution. Like one of the practice quiz problems we did today. But these are some of the trickiest ones because we get, and I get this too, I get into the mode of just following the procedure and then the next step is to square it and so on, but we can save a lot of time if we realize square root of anything has got to be positive. Alright, does that answer your question?
Yes.
Okay, and you are who? What's your
Vanessa.
name? Vanessa?
Vanessa.
Thank you, Vanessa. Any other questions?
Mr. Shankin?
Yes.
I'm sorry, I also had a question on 2.7, number 28.
Number 28. Alright, let's look at 28. Oh, that's the double square root. Alright, these take so long, 26, 27, and 28, that really I only had time today to do one. So I put that one in the practice quiz. But for number 28, let me just go over the procedure. The first step would be move this square root of x plus 1 to the other side. So get one square root symbol on each side. And then you square both sides, but you'll wind up having to square both sides twice because the square root on the left side will go away right away, but on the right side you're going to have to FOIL it out, and you'll get, after you FOIL it out, you'll get another square root showing up. So that's why you'll have to isolate that square root and then square both sides once again. And sorry, but we're not going to have enough time to do another one of these because they just take so darn long to do.
Mr. Shankin?
Yes.
I had asked about 2.7.
2.7, number 28?
Yes.
Okay. Great. Let me go to the page. Let's see. 177. Yes. No. How come I'm not getting this? 150, 160. That's right. So it's back further. 160. 2.7, number 28.
Yes. Sorry.
Okay. Let me. That. Alright, so on double inequalities, the arrows have to be pointing to the left for it to make sense. And what it's really saying is that this 3x plus 2 is trapped between negative 4 and 18. It's bigger than negative 4 on the left and smaller than or equal to 18 on the right. And what we can do is work on all three sides at once. Oops, it's supposed to be minus 2s everywhere. So I get minus 6 is less than 3x less than or equal to 16. And then I can still work on all three sides. I need to get the x isolated, so I get rid of a 3. And then this becomes x is greater than negative 2 and is less than or equal to 3 goes into 16 5 times and 1 remainder, so 5 1/3. And that would be my solution, and it asks you to write your answer in interval notation. And in interval notation, it looks like this. And if it doesn't include the endpoint, you put a parenthesis. If it does include that endpoint, put a bracket. And that's the final solution. Does that answer your question?
Yes, thank you.
You're welcome. Any other questions?
Number 31 on 2.7.
2.731. Okay. All right, now, when you have an OR, let me just do a real basic one. If we'd been asked to graph, let me go to a different color. Graph x is less than 2 or x is greater than or equal to 5. Now, what this would mean would be like this. I would go x is smaller than 2, x is greater than or equal to 5, like this. Okay, so graph this or this, these are the solutions right here. All right, so this might be a situation for like 2, 3, and 4-year-olds are all taken out of the school because they're on a special trip. And so who's left at the school? Just the people who are less than 2 years old and the people that are 5 or older, something like this. And now, so when you have the word or, both are solutions. And we talked briefly last time about or. I think I had something about like if I'm wearing a shirt or I'm wearing a hat. Only one of those had to be true for the statement to be true. It could both be true, but only one of them had to be true. All right, so now we're back over here. We solve each of these equations, and then we put them together with the word or. So I'm going to take this equation, and then this other equation, and then I'm going to divide by 2. Over here I'll divide by 5. I get x is less than negative 3 or x is greater than or equal to 1. And the answer, express your answer using inequalities and then write your answer in interval notation. Before I put it in interval notation, so there it is as an inequality. But I would graph it as well, just to add a little insight. And x is less than negative 3, or greater than or equal to 1, be this, and then if I wrote it in interval notation, this is way on the left is not infinity, it's negative infinity. We always have to go left to right. Even though the arrow points to the left, you can't say negative 3, comma, negative infinity. You have to go from left to right, negative infinity to negative 3, and then 1 to far right as possible. Keep going. You never get to infinity, that's why we don't put a bracket there. Always parenthesis around infinity or negative infinity. And you can put the word or in between these, but you'll see U for union. It means the same thing as or. But when we use interval notation, we use this U for union instead of the or. Does that answer your question?
Yes.
Okay. Anything else? All right, we will take a break now. We will start again. At 1:32 p.m. And does anybody need to talk to me individually for any reason before I take my break? All right, I'm going to take my break. All right, let's start up again. And we have 6 groups in this class. And let me get a countdown with each group. So everybody go to your group number and just type in hi. And group leader, make sure that the person who's the spokesman of the day knows who they are. And tell me how many is in each group. Group 1, how many of you? How about group 2? Oh, 1?
2 of us in group 1, sorry.
2 of us? 2 of you?
Yes.
Okay.
3, sorry, someone just...
Oh, somebody just came in, so 3? 3 of you. And then group 2?
There's 4 of us.
Group 3? Group 4? Group 5?
Looks like 2 of us in group 5.
Okay, and group 6?
There's 2 of us.
2. Okay, so group 6, I want you to join group 5 for today. So go to group 5 and unmute that channel. And so there'll be 4 of you in group 5, and we'll have groups 1, 2, and 5 today. And all right, so the section is modeling with linear functions. And this worksheet is called Review of Equations of Lines, and I pasted this worksheet right here into OneNote. So, number 1, you have purchased stock in an extremely risky startup company. On year 0, the year of your purchase, the price was $1 per share. X is the years the stock is owned, Y is the price of the stock. Okay. Now, this reminds me of when I was first playing around with the stock market, and this was, maybe, 30 years ago. And you might be curious to know that more than half of the U.S. population now owns some kind of stock. It's really quite prevalent in our society. A lot of people own stock because they're in a automatic retirement account when they join their work. They set aside a portion of money every month for retirement. It's kind of automatic in their program. It might be called a 401k program or something like this. And their work sets aside some portion of money for their retirement as well. And then if that money is going to sit there for a long time before you can even access it for your retirement, it's really important that you invest it wisely. And so that's why so many people have stocks now. And I had some money, and I was at a company that had a similar kind of retirement program, and we could manage our own money. And I decided, I'd put mine in stocks. But one thing that fascinated me was that there are stocks that cost as little as $1 per share. And I thought, if that stock ever goes up by $1, you just doubled your money. And so I remember tracking these stocks for a while that were $1 per share. And day after day after day after day, it was always $1 a share. They never moved, it seemed like to me. And eventually I got tired of tracking them. But, all right, so assume the stock in this company increases by $2 every year. Complete the table and graph the relationship. All right, so I'm going to give you all a little bit of time to do part 1A. Complete the table and make the graph. Thirty seconds more. Okay, so it's increasing by $2, so it goes to 3, and then to 5, and then to 7. And at year 0, it's $1. At year 1, it's $3. Year 2, it's $5. Year 3, it's $7. So we just get these dots, and then if you connected the dots, it would look like a straight line, like this. Okay, and let's go to B. Assume the stock increases in price by $3 every 2 years. Complete the table and graph the relationship. I'm going to give you a minute to do part B. So 30 seconds more. So I have this special tool, a Wacom tablet, that allows me to write right on my screen with this thing that looks like a pen. And I'm imagining you all having to, take your notes on pencil and paper and jot down very quick, rough sketches for things. So in 2 years, it goes up $3, so it'll go up to 4. Another 2 years goes by, it goes up to 7. Another 2 years goes by, it goes up to 10. 0, 1, 2, 4, 4, 7, 6, 10, and like once again, it looks like we could connect these. I'll just kind of connect in between this time, so we can see the dots. What looks like a straight line, like this. All right. So then, I'm going to ask you to give your answer to part C and D. In C, in which situation does stock rising faster, A or B? And then it asks you in D to give one number to describe how fast the stock is rising in situation A, and then give one number in decimal form to describe how fast the stock is rising in situation B, and give the units of this number. Alright, so I'm going to ask you to do these C, D, and E individually right now. So I'll give you a little bit of time for that. And hopefully you have OneNote on your computer so you can scroll back and forth to see both. But in case you can't, I'll try to get them both up here. Okay, and then go to your group chat and type in your answers for C, D, and E. But don't hit enter yet. Just go ahead and type them up as soon as you figure them out. Go ahead and hit enter in your group chat. Discuss this. Okay, so let me ask group 2. In which situation is the stock rising faster, A or B? So group 2, and you can say pass if you're not sure.
Sorry about that. Group A is rising faster, or A is rising faster.
A is rising faster. So now give one number to describe how fast the stock is rising in situation A.
1.
And you're going to say it's the one number is 1?
Yes, M equals 1.
M equals 1, okay? And then give one number in decimal form, so this is part E, to describe how fast the stock is rising in situation B, and give the units of this number. So
M equals 1.
M equals 1.5.
I don't know what the units are.
And not sure of the units. All right, but that's a great start. So your instinct was that it's going up faster in A than in B. And now, when I look at these two graphs, I see that the blue line in A seems to be steeper than the red line in B. So my instinct is, yeah, it looks like that's rising faster. So I'd agree with you on A. Give a number to describe how fast the stock is rising in situation A. Well, this 1, it'd be nice to get units with that, and with this one in the 1.5 right over here. The 1.5, so group 2, how did you get the 1.5?
We got it because M equals, because it is rising $3 every year, and half of that would be 1.5 because we can reduce it to that.
Ah, okay. So it went 3, I think it was the 3 over the 2. And that becomes the 1.5. And the 3, you said this was the rise. So every year it's rising $3. And the units of that is dollars. And every 2 years, so the units of this is years. So it's 1.5. The units would be dollars per year. That's how many dollars is rising per year. And now if we go back to part B, or part A, I think we'll change this value. If this one's rising faster, then it's one
I'm
number.
sorry. I see what it is now.
What is it now?
It's $2 per year.
Very good. We'll change that to $2 per year. Is how fast every year that goes by, it's going up with $2. And this one has a bigger number. So that, talking about its rise, the bigger the number, the faster the rise is. And you also had said an M over here, because these are slopes. Bigger the slope number, faster the rise. Alright, now let's go to F. For situation A, compute the slope between the first two points on the table. And then G, compute the slope between the last 2 points on the table. So both F and G refer to part A. And then, alright, so let me give you a moment to do F and G. Alright, so these indeed, 0, 1, and 1, 3, are the first 2 points on this table. They're just vertically arranged. And when we compute the slope between them, it's the difference in the y's over the difference in the x's. And that's the slope that we were being told. How fast is rising is $2 every year. And if we compute the slope between the second and the last point on the table. So there's the second point, and here 3,7 is the last point. We are going to get, in this case, M equals 7 minus 3 over this 3 minus 1. Alright, now notice the points don't have to be consecutive. We were computing the slope between this point and this point. It doesn't matter how far apart the points are. The slope still turns out to be the same. Alright. Notice that when we use the slope formula, we get a number that describes how fast the line is rising or falling. And positive means it's rising, negative it would be falling. How steep the line is. So this one was steeper than the other one because it had a slope of 2 instead of 1.5. And then the change, here's the big part for today. It's the change in the output each time the input increases by 1. The bigger the slope, the steeper the line. Alright, now this part, the change in the output each time the input increases by 1. Let's focus on that. Every time the input goes up by 1, the output goes up by 2. Every time this goes up by 1, this goes up by 2. And the ratio, this is called the rise, and this plus 1 is called the run. How much it's increasing each time. And the rise over the 1 is the slope. But if you make this equal to 1 for the run, then the rise will be the slope itself. And the slope will show up right there. Okay. All right. So now it says write the equation for situation A. Write the equation of that line that represents this situation. Remember, X is years, Y is price in stock. When you write this equation, it'll start with Y equals. So let me give you a minute to do that, and then part J asks you to write the equation for B. Alright, let me have you stop. When I write the equation of a line, I get stuck. I can see this table here, and I can see the graph, but how do I write the equation of the line? The thing that unsticks me is a form that I remember. Y equals mx plus b. Oh yeah, for a line, straight line. And so then I have been in situation A, we determined that its slope was 2. And then the B is the y-intercept, and situation A, it's 1. You can see it hits the y-axis at 1, and the y-intercept is always the output when the input is 0. Alright, so y equals 2x plus 1. So let me give you a minute to write the equation for situation B. So if you need to see it on my screen, I made it real small so you can see situation B and that. Alright, so this one is y equals mx plus b again. And this one's going to be y equals, now we said the slope here was 1.5. And then we look to see what is the y-intercept. In situation B, when the input was 0, the y output was 1 still. And it was there. Alright, now, number 2. At the beginning of year 3, the price of stock in Nike shoes is $8 per share. At the beginning of year 7, the price of stock in Nike shoes is $20 per share. Assume the stock price grew by the same amount every year. Find the rate of change, how fast the price of the stock is increasing per year. So let me give you a quick bit of time to find that. Okay, we're running a little short on time here, so I'm going to have to go here. If I need a little graph here, I'd put the year here and the price of the stock over here. And you can see that the points are in year 3, it's 8. Year 7, it's 20. So the rate of change is the same as slope. It's the interpretation of what the slope means. And it's the rise over the run. So 20 minus 8, 7 minus 4, 12 over 3, which is 4. Now, what were the units of each of these numbers? This was the year. This was the dollars. Yeah.
You put 7 minus 4. Shouldn't it be 7 minus 3?
Thank you very much. It's like my mind was working ahead. 7 minus 3 and 4, I mix these two up. So that's 3. Alright, so this is years in dollars. So this is, on the top, this is dollars minus dollars. So this is, it rose $12 in 4 years. And the units of slope will always be the units of the y-axis divided by the units of the x-axis. Dollars per year, in this case. And so it's rising $3 per year on average. All right, now it says to write the two forms of the equation of a line. There's slope-intercept form and point-slope form. And it might be a while since you've had these. See if you can jog your memory and write them down. Slope-intercept form is y equals mx plus b. Why is it called slope-intercept form? Because that's the slope and that's the y-intercept. Point-slope form, y minus y1 equals m x minus x1. And the point is x1, y1, which you see in there. And the slope is m, which is also there. So that's why it's called the point-slope form. Okay. Now, so Nike stock in year 3 was $8 and year 7 was $20. And now it asks us to find the equation of the line that passes through those points. And find the equation using the slope-intercept form. We're going to do it, and since we're running out of time, I'm going to have to do this. I would be having you guys work this out yourself, except we're running out of time. So we start with y equals mx plus b. And we have figured out the m was 3. So we plug that in. But we have to figure out what the b is to come up with the total equation of this line. How in the world am I going to find out what the b is to get the equation of this line? I'm going to open the floor. Anybody have an idea? How in the world can I find out what the b is?
This is Beverly. You need to manipulate the equation so that x will equal 0.
If you put x, when x is 0, that'll give you the y-intercept. So, and we could even look at the graph on this. So if we went 3 over, and we'd be 8 up. I'm just going to approximate it like that. And if we went 4, 5, 6, 7 over, it would be 20 up. We could look at this and imagine a line going through these and seeing where does it hit the y-axis, and that would be the b. Because when the x is 0, the y would, then we'd get the y-intercept right over here. So that's, when I do it like this, I'm going to guess that the y-intercept is like around 2 or something. Now, besides using a graph and coming up with it with approximation, we could also get the exact value of b if we notice this relationship. The 3 letters, there's 3 different unknown, there were 4 different letters that we didn't know at the first equation. X and y and m and b. Now this new equation, there's just 3, x, y, and b. Now, the x and y are what we call variables. The m and the b are constants. So, the variables, they get to vary. They get to play the what-if game. If the x is 3, the y will be 8. If the x is 7, the y will be 20. But the constants stay constant. The m is always 3. And the b will always be whatever it is. Alright, so what we're going to do is we're going to take 1, and it doesn't matter which one we take, 3, 8, or 7, 20. Let's plug in x equals 3, y equals 8. Because that's one possible for instance. We could have also plugged in x equals 7 and y equals 20. If we do that, we're going to be able to figure out what b is. 8 equals 3, the x is 3 plus b. So this turns out to be 9. Subtract 9 from both sides, b is -1. So now I feel like, wow, good thing I didn't rely on my picture too much, because that wasn't a very good picture. This is showing that the b is -1. So then y equals 3x minus 1 appears to be the equation of the line from using the point slope form. Now we're asked, find the equation. No, that was slope intercept form. Now we're going to find the equation using the point slope form. So I'm going to start this one with y minus y1 equals m x minus x1. And I'm going to come out with the same answer, but I'm going to do it in this way. I'm going to use x1 comma y1 equals either one of these points. Now, I used the 0.38 last time. Let me use the 0.720 this time. Doesn't matter which one I use. Now, I also know that my m is 3. We computed the m up here and got 3. So we're going to plug these things in. Y minus the y1, which is 20, equals m 3, x minus the x1, which is 7. Y minus 20 is 3x minus 21. Add 20. We get y equals 3x minus 1. We get the same equation that we got either method that we use. Any questions? All right, now I forgot to put, when I put numbers, I need to put pound sign, number 1 and number 2. When I forget to do that, these things renumber everything. This OneNote is crazy about that, and it renumbers all my stuff. And so all these numbers don't really make sense. It's starting over with number 1. Use the equation of this line to predict the price of the stock. Oh, I know why I didn't do it, because I had copied and pasted this from a worksheet. All right. Use the equation of this line to predict the price of the stock in year 13. So, X, again, is the year. Y is price of the stock. And we see Y equals 3x minus 1. So, year 13, 13, is that an X or is that a Y? Well, we look over here. It's clearly an X because it's the year. Use this line to predict the price, Y, when the X is 13. So Y is going to equal 3 times 13 minus 1. 3 times 13 is 39. 39 minus 1 is 38. So, in year 13, price will be $38 per share. If it kept rising at the same rate. Alright. And there's another situation. You are collecting chicken eggs for a very large order. On day 4, you have 13 eggs. On day 9, you have 28 eggs. The hen lays the same number of eggs every day. All right, that the hen lays the same number of eggs every day is important. That makes it a straight line. Okay, so it says on number 3, find the rate at which hens are laying eggs. That's the same as the slope. Now you have 2 points. On day 4, you have 13 eggs. On day 9, you have 28 eggs. So, my slope, M, is going to be difference in the y's and that's 15 over 5, which is 3. And we can write down the units of this. If these were eggs and these were days, so it's eggs per day. So that chicken that you have is laying 3 eggs every day. And then find the equation of this line. And we can use either form of the equation of the line. Now, when you have a choice, most people will choose the point slope form. It goes a little quicker. Y minus y1 equals mx minus x1. So we can take one of these points. Suppose we take the first one. Y minus 13 is equal to 3, x minus 4. And then we can get the equation of the line and so on. Okay. And similar types of questions that it has here, then use the equation of the line to predict how many you'll have on day 24 and so on. So 4.2, that's going to be your homework. And all of its problems will be application problems of linear situations. 2 forms of the equation of the line. You need both of those. You need to have those things memorized. So practice memorizing those. Every time you need them, write them down from memory and then check that you wrote them down correctly. And are there any questions? And does anybody need to speak with me about anything? All right, I'm going to stop recording.